Okay, so for this next one, we're going to find the angular momentum of this system of particles here. Okay, so the angular momentum of a system would be the sum of the angular momentums of each of the particles that make up the system. So in this case, we have two particles. We want to combine their angular momentums. Okay, remember that angular momentum of a particle is r cross p, or m times r cross v. And remember that cross means make them perpendicular. Okay, so in this case, we're already given the momentum. Okay, so particle 1 is going to have a momentum of 5 kilogram meters per second. Okay, and it tells us that it will pass within 2 meters. So what it's saying is this distance here is 2 meters. Remember, for the perpendicular radius, all we have to do is find the place where it will come closest to the particle, whether it's already past it or it's on its way there. In the case that it already passed, it would be the place that it would have come closest. You just kind of draw a line through it and see the place where that line comes closest, which is right here, which is at a distance of 2 meters. Okay, and this is a counterclockwise angular momentum, right? If it were to get caught by a string, it would start to spin this way. And so for L2, it has a momentum of 2 kilogram meters per second. And for this one, it's going to pass within 4 meters. Okay, so this distance here, 4 meters. And for this one, it's going to cause it to rotate clockwise, which means this one is negative. So we get 10 kilogram meters squared per second minus 8 kilogram meters squared per second, giving us a total angular momentum for the system of 2 kilogram meters squared per second. Okay? Pretty straightforward. Okay? And let's say there was 4 more particles, then we would add 4 more on. Okay? Here's another one. This is a little penguin. He's jumping off this little cliff here into the water. And the question is, what is the angular momentum of the penguin about point O in terms of d, m, g, and t? Okay, so angular momentum for a particle is r cross p. Okay, so that would be m times r cross v. Okay, well, for this penguin, we don't know what his momentum is because he's been falling. There's 2 ways that we can do it. We can take the amount of force acting on him and multiply it by the time, which is mg times t, and that will give us his momentum. Okay, since the impulse force times time is the change in momentum. And then, given that, we can multiply mgt, his momentum, times his perpendicular radius, so the place where he would have passed the closest. If we trace this line back, the closest he was to that point was a distance d, so that'd be d mgt would be equal to L. Okay, the other option here is to find the velocity. So since he's in free fall, we know that he experiences acceleration g. We can use this equation here to find the final velocity. Okay, well, if initial velocity is equal to 0, that means that v is equal to g times t. Okay, we're allowed to use both g and t here in our answer. And so we'd say, okay, we're going to multiply m. Again, the radius here, that perpendicular distance, is going to be d times the velocity, gt. Okay, so again, we get d m gt for our angular momentum, solving it either way. Okay, then it asks for the torque on the penguin from the gravitational force. Alright, 2 options here. Remember, torque is equal to the force times the perpendicular radius. Okay, well, the force pulling the penguin down is equal to the weight of the penguin, and in this case, the distance, or the radius, would be d. Okay, So there we have our distance d, so mg times d would be the torque. The other way, though, is that torque is equal to the change in angular momentum with respect to time. So we could say, okay, d of dm/gt over dt, we're going to take the derivative, and we end up with just dmg. Okay, same thing we got there. Okay, so that was two ways you could find the torque on the penguin, and then we had two ways where you could find the angular momentum, and really if you knew that this was the torque, you could also use that to find angular momentum by integrating from 0 to t, right? Because then the torque would, or the angular momentum would be equal to the integral of the torque with respect to time. Okay, and then you would end up with this. Okay, torque, angular momentum, there you go.